In 2015, an AEC startup, Katerra, launched with much fanfare, billions in venture backing, yes, billions with a B, and a bold plan to reinvent the industry. Its idea? Standardize designs, prefabricate components in factories, and manage everything in a single software platform. People were calling it the Tesla of construction. But 6 years later, it collapsed. Why? Ultimately, extreme standardization proved too hard. Every project really is different. Factory-built components still had to be installed on unpredictable sites where delays were unavoidable. Plus, their software, built for an orderly world, couldn't handle the messiness of last-minute changes, missing parts, and constant surprises. These obstacles were not unique to Katerra. The same barriers have prevented the industry from achieving the kind of productivity gains seen in other industries. So, is innovation in AEC dead? No. There are indeed some significant technological frontiers. Some of these frontiers relate to physical technologies. For one, new building techniques. For example, 3D printing speeds up production of prefabricated or prefab components like wall panels. Another example is the use of interlocking brick systems that slot together without mortar. These reduce build time dramatically. For two, there are new materials innovations, like self-healing concrete, which uses bacteria to automatically seal its own cracks, reducing maintenance costs. And for three, there are new equipment innovations. For example, drilling robots that can install ceiling fixtures faster and more precisely than workers. Other innovations are digital. Software solutions are nothing new. Recall that most projects today use building information modeling software. But new 4D BIM goes beyond static models, letting teams simulate designs as they advance through the construction process. This can spot process conflicts. The use of AI tools is on the rise too. AI has use cases at every stage of a project. For example, in the bidding process, machine learning models can better estimate project costs and timescales. Or during construction, computer vision tools can scan sites for safety hazards, reducing accidents, delays, and insurance premiums. Computer vision can also document exactly what was built, creating a true-to-life digital model that can be fed into BIM systems. This is called field-to-BIM. There are other trends beyond innovation. One is a shortage of skilled labor. While demand for construction work continues to rise, the supply of workers isn't keeping up. Fewer young people are entering the industry, preferring air-conditioned offices over construction sites. This imbalance means firms are increasing wages and offering perks like shorter working hours to attract talent. It's also accelerating the adoption of productivity-boosting tech. Higher labor costs means faster payback on tech investments. The final trend is a growing focus on the industry's sustainability and environmental impact. Partly, this is about reducing waste. By some estimates, AEC accounts for 30% of global waste. Think rubble, scrap steel, and wood. Aside from greater pressure to recycle materials from decommissioned buildings, there's also a push to reduce rework, which is a big contributor to waste. Technology can help here, too. For example, augmented reality tools let workers visualize how elements fit before installing them, reducing errors. Better sustainability is also about reducing emissions. That applies to the construction process itself, say switching from diesel generators to electric ones, to the materials used, say switching from concrete or steel to lower carbon materials like cross-laminated timber, and to the carbon footprint of a building through its lifetime. For example, heat recovery systems that take waste heat from server rooms or showers and redirect it to cooler areas, reducing energy demand.